Let's go on taking a look at some examples dealing with the creation of sheet metal objects modeled and obtained by using the standard features of solid objects. The creation of sheet metal objects can be achieved also starting from existing objects. This can be very useful, especially when you receive a modeled object from someone else and you have to make it a sheet metal object which you can easily unbend and rebend. Let's now load file 5_Carter_solid. Taking this electric engine as the starting point, we shall create its case. We have already seen how we could create a case with the typical sheet metal features, flanges, bends, rips, etc. Now let us start creating it with the typical features of solids. Let us then start from the linear extrusion of the profile we can see at the very bottom of the model. Let's launch the linear strip command. Then let us select the profile, specify a depth of 120 and confirm by clicking OK on top of the selection list. Let us turn on the Named Views dialog box. Let's go on creating the fillets, first on the edges that are going to be the external bends using the edge fillet command. Let's assign the fillet on outermost edges a 3 mm radius. We're rotating the model to see which these edges are, and the 1 mm radius to the fillets on the edges that are going to be the internal bends. Eventually, when we're done with the external fillets, let's assign the fillet of the base edge of the solid a 3 mm radius. And now we have a fully filled object, and we can empty it, assign it an appropriate thickness using the shell command. Let's set the thickness to 2 mm and let's remove the outermost front face of the object. Let's confirm and close the shell solid command. The consequence, we get the fillets on the edges of the solid which we have added a thickness to, with the radius values computed with the thickness value assigned. At such an extent, we need to make the object bendable by creating the necessary rips. We have sharp edges on the top part of the object, while at the bottom we have the fillets with the radii we have previously set. And here are the fillets we were talking about. On such fillets, we can create rips using the face rip command. Let us then select the set fillets, obviously skipping the one on the right hand part of the object, which are then removed, leaving some openings, as we shall see. Let us complete our selection, selecting each single fillet and confirm the command. So we have created the rips by removing the faces. Now let's get back to the top face. So we rotate the model. Let us view it, optimizing it. Let's apply the edge rip command to all side edges, of course, except the front and rear transversal ones. Let's apply them. So let's select all the said edges. Of course, we are rotating the model so as to facilitate our selection. So let's go on and complete the selection of our edges of the top face and then confirm. But in this position we have a very low length piece. The length is 0.354, which might cause problems when trying to unbend the object. So you can see the small piece. There it is, 0.35. Now let's try to unbend it, but when we select our face, ThinkDesign will issue a message to inform us it will not be possible to make all the side faces normal to the bend plane. If we go on confirming in this position of the plane development, there might be problems. Therefore, let us roll one step back, practically removing the plane development. Let us rebuild the model, and finally from the history tree let us redefine the rip on edge feature. Let's unlock the gap by clicking on the lock, close to it, so as to be able to locally redefine the value of the gap, which is predefined in the global properties, changing it from 0.5 to 1. Finally, let's apply the modification by clicking the green traffic light on top of the selection list. We can observe that the gap has increased, even more than doubled, and it's about 0.7 millimeters. Now, rather than obtaining the bend automatically using unbend and rebend, where the system would insert an inner radius of 2 millimeters, we shall use the global properties. Edit property sheet metal. The inner radius for the bend is just of 2 millimeters. Let's select the bend command. In the bend on drop-down list, let us select sharp edge fillet, and let us select the fillet on the rear edge of the top face of our case. In the radius box, let's input the 0.7 millimeters value and let's apply. So 0.7 millimeters, apply. Now let's develop our object using unbend. But first let's take a look at what we have got in the corner. Just by enlarging that part, as you can see, the situation is okay, because the fillet is 0.7, the length of the gap is 0.7, and so we're okay. Now let's unbend it, selecting the rear face, and let's rebend it using rebend, only selecting the rear internal face. To actually complete our cutter, we should create also the slots where to make the electric parts of the engine pass. But we shall not do it now. So we shall close our model without saving it. And now let's create the case again, but with another method. With this goal, let us load file 6_carter_solid B.3. Let's extrude the base profile again, that in this case is open, using linear solid. Adding the thickness value from the very start, let us select the thickness checkbox on the model, and let's assign a value of 2 mm towards the internal side. Now let us confirm. Now let's start the unbend command, and let's select the vertical rear face. And now let's apply rebend, selecting the same face. After completing these two operations, the bend with internal radius of 2 mm are assigned to sharp edges, according to the global setting of sheet metal. Then let us insert a flange, starting from the back edge until a point on the internal part of the back wall of the carter. Let's start the flange command, and let's select first the edge of the rear face. Then let's select the up to point mode in the length drop-down list. Let's specify the target point of the flange on the edge of the internal part of the front wall. So the flange gets created. Now let us add another flange, and to do this we first rotate our model properly. Let's start the flange command, leaving the length mode set to by value, and let us input a 38 mm length value. Let's then expand more options. Let's select the extension box, choose the first distance and second distance method, and let's input a value of 26 mm in both first distance and second distance boxes. Then let's also add an offset, selecting the offset checkbox in the selection list. We shall show how an offset is not necessarily used only to add material, but also to remove it. In fact, we set a value of 4 millimeters towards the internal side, properly setting the handle. In this case, we also have bend reliefs, as you can see, and we shall indicate. But here they are. We shall disable them from the local properties. Therefore, let's click on the solid icon in the history tree, and let's choose Edit Properties and open the Bend Reliefs tab. Then let's uncheck the Enable box. Then let's confirm using OK on the Properties window. We're going now to add a closure. So let's optimize the model, and let us place the work plane onto the right front face using the work plane here contextual command. We shall use a profile. So let's open the 2D profile environment, in which we shall create a rectangle. We have enlarged the proper region. Now let's start a rectangle command. As the first vertex, let us specify this one here, and then using the snap tool point on curve, let's specify the right hand edge. Then back to the model environment, let us properly rotate and view our model, and then let us start the linear protrusion command. Let us first select the profile we have just created. The system points out a depth of 2 millimeters, which is exactly the thickness of our cutter. Let's confirm the creation of the protrusion. Back to the 2D profile environment, let's create a profile always on the same work plane, which coincides with the external face of the protrusion. Starting from the middle point of the superior edge of the protrusion, let's draw the following 3 lines through 2 points, which we'll use to create a rip. Back to the model environment, we are now able to start to create our rip using command sketched rip. Select the just created profile and this line face. Increase the gap value under local properties from 0.5 to 1. Let's confirm and the rip is created. Now we move the work plane onto the internal top vertex of the just created rip using command Edit Work Plane Move and selecting the vertex. Then let's rotate it using the aligning command for the work plane. As you can see here, align z-axis and aligning the z-axis to the topmost edge of the case front wall. Now back to the 2D profile environment. Let's properly rotate the model, and then we shall create a polyline. Starting from the work plane origin, inserting 2 lines, the former horizontal and the latter vertical. After we have created them, we shall put on them some dimensions, which will be 30 in horizontal and 10 in vertical, as you can see. And now let's go back to the model environment. Let's start the Extruded Flange command. And the profile just created is already selected. Let's set the type to tangency chain and then select the upper border. Under local properties, let's unlock the lock close to alignment and let's set the letter to outer flange. Let's confirm. The flange is created with the desired rips, and you can take a look at it. And now let us obtain the plane development of the case using the unbend command and selecting this face here. Here we have the development. And now we shall optimize the view. The exercise is over.